working with Philippe, and I am also a visiting researcher at the Institute for Computer Music and Sound Technologies at the Zurich University of the Arts in Switzerland, and there I'm working mostly with Daniel Bissek. And today I want to talk about our live audiovisual performance called Revive. So in the beginning, I really wanted to maybe talk about like future directions of how to use machine learning for intermedia mapping, but then I realized it would be, I think, really beneficial for everybody to maybe kind of understand what kind of mapping is happening in a live audiovisual performance, and I kind of want to draw how that's different, probably from a case of designing digital musical instruments. Revive is a live audiovisual performance where we play with an autonomous musical agent. It's an interactive music system. And there are 3 performers in Revive: myself, Philippe, and this system that we call Mason. Mason is a musical agent based on self-organizing maps. It is working with audio. It applies unsupervised learning. The idea is that you just curate an audio dataset and you give it to the computer, and it learns from the raw audio, and it's able to listen to the live audio as well while performing with you. But before going too much into the details of the system, maybe I should just clarify that a musical agent, we choose to define musical agents as partially or as systems that partially or completely automate musical tasks. And if you are interested in what do we mean by musical, what do we mean by agents, how does that correspond to the literature of multi-agent systems and the literature of music, we surveyed 78 musical agent systems to come up with a typology and maybe clarify future steps. And we ended up with a journal paper which is 50 pages of pure fun, 35,000 words for you, just to enjoy at least for like 2 weeks. So I'm not going to cover that here because I'm limited in time. But if you're interested, it's published in the Journal of New Music Research. Taking a step back, in Revive, we are using the interactive music system called Mason. So I like doing blah blah, but we are also making music, so let's hear it maybe before the blah blah. The video includes 3 excerpts. All those 3 sections that you heard that were distinctly that had distinct styles were generated by the same model, but with 3 different temporality conflicts. And there are more examples on my webpage if you're interested, and all the documentation and the publication is there. So what was the inspiration behind? I really like the idea of organized sound that's proposed by Edgar Borges. He said that I decided to call my music organized sound, and myself not a musician, but a worker in rhythms, frequencies, and intensities. And then my question was, if music is organized sound, then how do we teach the machine how to organize sound? And in my PhD, I came up with 2 different types of sound organization. First one is organizing sound in audio space so that similar sounds locate closer to each other, and then the organization in time, sound organization in time. That is how do we organize sound objects in time series. There, I think we have. So here, I'm going to pinpoint where I think there's some sort of mapping. I don't know if it's okay to define that as mapping, but I just want to throw it in your face there. And I think the first place that something like mapping is happening is here, because you are taking an object and you are putting that in time series. So if mapping is some sort of correspondence, then here we are asking where does this sound object correspond in time? And there were discussions in the previous days about iteration and how we design systems and how iteration is involved in the designing and mapping. And here I want to mention the machine listening algorithm in Mason, where we came up with 35-dimensional label vector with timbre features, loudness, duration, and emotion recognition features. And here I started from actually the music emotion recognition features. I was just trying to have a musical agent that was using pleasantness and eventfulness. And by listening to the output of the agent, then we thought that, okay, you know what, it seems like the agent doesn't know what timbre is, maybe we should add timbre features. And from there, we did more experiments with electroacoustic music instead of just noise, and then we realized that maybe we should add loudness, and the duration was really nice because it's emerged some sort of understanding of temporality, but with different time durations. So you may call it iteration evaluation loop, or you may call it an electroacoustic music action perception loop, whatever you call it. There's some sort of evaluation, and then doing another pass on the design is happening for sure. Going back to Revive, so that was Mason. Then how we kind of build the live audiovisual performance on top of an autonomous music system. Of course, before doing the blah blah, I wanna play some sounds. This is what we call a dome view. And this piece is originally made for the SAT Montreal, Society of Art and Technology. And they have a dome that is, I think, 30 meters in diameter. They have 157 speakers that is clustered to, when we were performing that, were clustered to 31 channels. So they have a full 3D audio setup with a dome view. And here you see three different visualizations that corresponds to three different sonic performers. And we talked about Mason World, and I want to talk about what I do and what Philippe does in this performance. So Philippe is using this Behringer controller with a software called Canaxis that's made by Stefan Shumolopis. He's also an artist in Vancouver. And here you go, your second type of mapping that's probably the most common one, that is controller to sound generation. And I'm using an Xbox controller where two things are happening. First, I'm doing again a mapping from from the parameters of the controller to the parameters of the sound generation. But also, there's I think a third type of mapping that's from controller to the sound location. So to do that, we see this joystick is controlling the sound generation, where the x-axis is the time stretch and y-axis is the pitch shift. And I'm using a wavetable synthesis where I could just change the window live using the trigger buttons, and and then the joystick on the right is controlling the sound location. But if you realize this joystick just generates an 2D output, I'm taking that 2D output and mapping that on a surface of a sphere because I need to locate the sound on 3D. And there you go, that's your third type of mapping, I would say. Then, for the visuals, we are using engines that are audio reactive. So we have 3 visual engines that are mostly similar to each other with slight differences. And they are all listening to the outputs of our live performance because it's structured improvisation. Interesting. I don't know what's happening. That's not me.
You Sofian?
Oh yeah, someone connected.
Yeah.
Interesting. Going back to the visual engine, there are 3 performers and then there are 3 visual engines that and visual engines are listening to the audio features of the performance. We are doing structured improvisation in the sense that we have some roles, but within those roles we are improvising. And that's why it was important to have also the visuals almost like an with a flexibility that would react to the audio output because we don't know what we would be playing. We have an idea, but it's not for certain. And there you go, another mapping from audio features to the parameters of visuals for visualization. And then there is another type of mapping. This is the 5th one. Is the special location of sound and special location of visuals. So this was a piece that's made for the dome, and our initial idea was to synchronize the audio spatialization with the location of visuals as well. And this is almost like a no-brainer if you're an audience member, but if you actually apply it, if you actually develop it, then you need to have a synchronization that's corresponding to each other because you're not generating sound and visuals together. And to run the whole show, we are using a queue system. We were using the scripting in Jamama, where each queue is a section in the performance. And within queues, we were using the ramp function of Jamama a lot actually to develop the piece almost like a composition, and which I think gave us a lot of flexibility to not think about anything related to the parameters, but just be in the performance. So to sum up all the mapping types, we first talked about the mapping inside Mason, which was sound object to the temporality, time series. And then we talked about controller to sound generation, which Flip is using to perform. And then we talked about controller to sound location, which is automized, which is happening in my case, but it's automatized for Mason and Flip. Within every queue, within every section, there's an automatic specialization going on for Mason and Flip's output. And then we also have a 4th type of mapping that is audio features to visual engine parameters. And then we also have, to synchronize audio and the generated visuals at the end, we also have a mapping from special location of sound to the special location of visuals. And this could be a no-brainer in the case of Dome, because the sound specialization is almost like a square, and the visuals are, it's almost kind of like mapping is right there. But if you change the setup, it's not always the case that you end up with a dome. If you really change the setup, then everything becomes really interesting, because here we are taking that visual scene and we are actually like shrinking it down to a really almost like a stretched rectangle. And there, I need to use the same audio specialization somehow and take that that 3D specialization and map that to this new visualization surface. And that's why it was important, I think, have some sort of flexibility there. Because this setup, for example, we just had maybe 2-3 hours just to be able to both set the audio and the visuals as well. So that synchronization becomes then a more complex case. And that's pretty much it. Questions? Yeah.
Questions? If someone has questions, can ask. Sofiane will be here very soon.
Yeah.
Yes.
Well, I have a question. Could we do all of those mappings with OSIA or LibMapper?
Yes. If I can just jump in, yes.
Yeah.
No. With LibMapper, can you script it?
What do you mean by that?
Yeah, exactly.
Changing in time.
So,
Every different settings and like interpolate
Ah.
between
so the
settings.
Q system has to be, there has to be a hyperparameter control.
Hmm.
So I need to be able to change the mapping between sections. And I need to be able to develop that mapping if I want between sections. For example, let's say there's a blur parameter in the visual engine. And I want to increase that as a compositional act. I want to increase that in, like, let's say 5 minutes within a section. And at the end, I want to have a really blurry image.
Right.
But that requires a change, for example, in the magnitude from one parameter to another. And things like that. This is a simple case, but if there's scripting, then yes, I can. If there's not, then I can't.
Well, I kind of repeat this argument a few times this week, but I think it's a matter of perspective, whether or not you think of things as being having different mappings over time, or whether or not those are actually could be part of one instrument, and you choose to access different parts of it over time.
It's not
Right.
an instrument, though.
No, I agree that your perspective is that it's not an instrument. I'm saying in terms of a technical implementation, you don't need. It's not necessarily true, without examining the exact details of what you're doing, that it would be necessary to script it over time. I'm positing that it might be possible to implement your system in a way, in the perspective that Travis is saying that LibMapper could handle it. I'm not saying that LibMapper is the best tool to do things according to your practice, right? But there's a difference between that and saying it's not possible to represent these structures without using time-based like queue system.
So it would be a little bit of a workaround, though. But I see what you mean. But what Kivanç is bringing in is here this importance of having the mappings, but having control over them over time. And so that's really this idea that we've been talking and alluding to since the beginning of the week of integrating a bit LibMapper and OSIA. Having LibMapper as a device, and then you can create different mappings, different instances of different mappings of the mappers and move from one mapping to another, which is exactly what we're doing here. And the agent is doing it internally, because when we change scene, the agent, that's what the piece is called Revive, it's been learning from the recordings of a dead composer, and we changed the mind of the agents a number of times so that the agents get to imitate a number of dead composers live on stage with us, and the title Revive. But so those things that have to change dynamically, and they have to change in a gracious way. Like it can't just be like a click or a blank, right? So, and that's sort of added challenge.
I think I have a simple way. Do you mind if you might be going to say the same kind of thing. But here's a simple concept of how what I'm saying would apply exactly. So we all know about interpolation spaces, where we usually say there's some like parameter state associated, maybe it's a 2D space, and I place them, and then I move around and I'm interpolating between them. So now imagine that those states, like my examples, are actually mappings, and then by interpolating, I'm changing a weight between one mapping and another. Now it's easy to take that structure and then decompose it into the individual, say, connections in LibMapper, and just add the interpolation signal as an additional variable in the expression. And then I've expressed it as a mapping the mapping remains the same over time, but I perform it, and one of my performance inputs is this, from one perspective, we can think of it as an interpolation way. So I'm kind of accessing different areas of control, I don't know, in some space. There's different ways of viewing them, and I think I'm not suggesting that everyone should adopt one way and use libmapper or something. We should be using the tools that match our concept of the piece or our own artistic practice.
But you would still need a QList and a temporal engine to control that parameter, right?
No.
You
No,
could
you
do
just
it
need
that
some
way.
input, which could be time. It could be like compositional, or it could be that you're controlling it yourself, or a co-performer, or an agent, or right. Because I'd say an agent is a performer, not a scorer. Right?
Then you would lose the constraints though, which I think is really important in terms of performance.
I think what I just suggested, you would exactly maintain all of the constraints if you view it that way. Because the structure that I just suggested, the interpolation, like changing these weights, could be run by a time-based system, for example, and then you would have exactly the same output as what you're suggesting.
Yeah,
But the mapping structure would be different. It would be a single mapping instead of switching between scenes of mappings.
Yeah, but sometimes, like from a mapping to another mapping, it's not just interpolating, because maybe sometimes, and like that's what I wanted to ask you, we want to ramp from some parameters of a mapping to not some other parameters, but some you just want to switch like abruptly, and some maybe you don't want to like introduce at the same rhythm, and you want to make some kind of composition between the two mappings. And like my question was, like, do you like apply the ramps also on the mapping parameters, or is it just like ramping from just getting some like nice fading of some sound and fade it out?
No, with every parameter there's the ramps and everything, and also another issue with the one type of mapping would be the so with every performance, this was I think performed maybe 6 times now. With every performance we have a different length. We have a different setup as well. So within all those, I need to be able to be flexible so that maybe I could take some cues out, put some new ones in, and change the composition towards what I have as a performance as next. That, I mean, yes, I do understand that like what you propose is totally, in my mind, it's the same as what the script does, in the sense that like you have some sort of temporality going on, and that temporality affects the mapping parameters or the parameters of the performance. But that being said, I really want to have blocks which are sections in the performance, and I want to be able to move them around.
So you want a time-based representation that you would manipulate, or
sort of, just because of the flexibility of it, and the speed that I could just do that within one rehearsal.
Yeah. I mean, I would argue that the single mapping structure is much more flexible because there is no ordering hard-coded into it at all. You would just choose to perform something differently. You wouldn't need to change your code at all in order to change the length of the piece or change the order of something.
You could prefer that, but in a complex environment like this, I would not prefer that because it's like there's so much going on that I'm sure that I would forget to change one parameter with certain scenes. So I would like to have some of them being automatized so that I have an actual perceptual energy in the performance.
Sorry, Martin, I cut you off so many times. I won't do it this time.
It's a slightly different notebook. You seemed adamant saying that it was not an instrument. Why do you say it's not?
The performance is not an instrument. It's a
No,
performance.
not the performance, but the instrument.
There is instruments. There is instruments within the performance. Yes,
Okay.
The performance itself is not an instrument, and that's why that's the conclusion that I wanted to make. There is also mappings and all sorts of other applications that's not necessarily digital musical instruments. For example, within the interactive music system, there's also mapping that may end up creating emergent behaviors. And also, you could have mappings, for example, just to have synchronization from the location of the audio toward the location of the visuals. So there, I just wanted to make almost like a note that we also have mapping in other cases. I don't know if we should call them mapping or something else, but in a real world scenario, these are the things that I encountered that I want to share.
We can continue this discussion I think, later.
So I have a question / provocation. A lot of what you're talking about is identifying types of mappings. So the mapping from controller to sound parameters, or mapping from a controller to the location of a sound in space. Mapping from the location of a sound in space to the location of visuals in space. These sorts of types of mapping.
Yeah.
And I guess it seems to me that when you identify a type of mapping, you imply that mappings within this type should have something in common that could be generalized across mappings within this type. Is that actually true, though? In the sense that just because I have a mapping that's a mapping from sound location to visual location, if the sound location topology is totally different in one scenario or another, just because they're the same type of mapping, is there actually anything generalizable between those two types of mappings, or those two instances of that type of mapping?
I couldn't care less about if it is generalizable or not, but I do know that in practice, I have a mapping from the controller space to 3D audio space, and I need to change that from performance to performance. So I need a tool for that. Whatever you call, if you call it mapping, I'm fine with it. If you call it something else like blah blah, I'm fine with it. But I do know that I need a tool that is flexible for me to do that super quick, so that I can fit everything within a rehearsal schedule of 2-3 hours.
Right. But do you need a tool specifically for the controller to sound location mapping that's different from the tool you use for any of the other mappings?
No, not really. But it's just, I want to make clear that, like, this is a really, if I wasn't a technical person, this would be almost impossible for me to do. So maybe we should talk about, like, how to disseminate this kind of application toward artists that are not that technical, and what would be the tools maybe so that we could enable them to do things like this without having technical background.
Cool. Thank you.
Yeah. Move to the
Yes.
next.